right, example 4. We want to simplify and always break down your radical first and then rationalize. So if there are any perfect squares within the numerator or denominator, go ahead and break those down first. So this would equal a negative square root of 9 times 2 over 25 times 5. And then I can rewrite this as negative 3 square root of 2 over 5 square root of 5. All right, then I'm going to rationalize the denominator. And I'm not worried about this 5. I'm just trying to rationalize this square root of 5 only. So actually, let me just highlight here. I'm only trying to rationalize the square root of 5. So I'll multiply by the square root of 5 in order to rationalize. So this will be negative 3 square root of 10 over 5 times the square root of 25. And I got that because I'm multiplying these two square roots. All right, the square root of 25 is 5. So that's negative 3 square root of 10 over 5 times 5, which is 25. And that's the final answer. All right, part B. We have the square root of 50m to the 4th over p to the 5th. First thing we want to do is break down the square root, find any perfect squares. So in the numerator, and I'll just separate these out. So the numerator will be 25 times 2, m to the 4th, over the square root of p to the 4th times p. So the perfect squares would be the 25, the m to the 4th, and the p to the 4th. So that now equals 5m squared times the square root of 2 over p squared times the square root of p. And then I want to rationalize this square root of p by multiplying the numerator and denominator by the square root of p. So now that equals 5m squared square root of 2p over p squared times the square root of p squared. And the square root of p squared is p. So now I have 5m squared square root of 2p over p cubed. All right, example 5, same concept, but this time it's a cube root. So we want to look for any perfect cubes before we rationalize. So first, I'm going to rewrite this as the cube root of 9 times, I'm sorry, no. 27 is a perfect cube, sorry. Cube root of 27 over the cube root of 8 times 2. So now the cube root of 27 is 3. The cube root of 8 is 2. So I'm left with 2 cube root of 2 in the denominator. All right, now to rationalize a perfect cube, that means I need a perfect cube. So since I have 2 to the first power, I would need 2 more 2's in order to make it a perfect cube. In other words, 2 to the third power, or 8, is the perfect cube. So I'm going to rationalize by multiplying by the cube root of 2 squared. 2 to the first times 2 squared is 2 to the third, or 8, and that is a perfect cube. So top and bottom by the cube root of 2 squared. So that would equal 3 cube root of 2 squared is actually 4 over 2 times the cube root of 2 cubed. You can write that as 2 cubed, or you can write it as 8 But just know when you take the cube root of it, it's going to come out as 2. So the final answer is 3 cube root of 4 over 2 times 2, which is 4. Let's do part B. All right, this time it's a fourth root of 5x over z. So I like to split it up first. So I'll write that as the fourth root of 5x over the fourth root of z. I have z to the first power, so that means I need 3 more. So I'm going to rationalize by multiplying by the fourth root of z to the third. All right, so now I have the fourth root of 5x z to the third in the numerator, and the fourth root of z to the fourth in the denominator, because when I multiply these two, that's the fourth root of z to the fourth, which is just z. So the final answer is the fourth root of 5x z cubed over z. All right, so now we're going to rationalize a denominator by using the difference of two squares. So we're rationalizing a binomial denominator. To do that, think about what we just did with the previous examples with FOIL. So if I FOIL here, I end up with the difference of two squares. If I FOIL with radicals, something similar happens, but I end up with, instead of a squared minus b squared, I end up with a minus b. And that always happens when you are doing the difference of squares with radicals. Okay. So example 6, if I want to get rid of this radical, I'm going to turn that into something similar to the difference of two squares. So I'm going to multiply both top and bottom by 1 minus the square root of 2. Okay, and so now you can FOIL the denominator and distribute in the numerator. So in the numerator, when you distribute, you end up with 3 minus 3 square root of 2. All right, you're going to FOIL in the denominator, and you'll end up with 1 minus square root of 2 plus square root of 2 minus the square root of 2 squared, or the square root of 4. Those middle terms will cancel out. So now I have 3 minus 3 square root of 2 in the numerator and 1 minus 2 in the denominator, because the square root of 4 is 2. And then 1 minus 2 is negative 1. So I have 3 minus 3 square root of 2 over negative 1. Now you can leave your answer that way if you want to, or you can distribute it through. So that would be the same as, when I say distribute it through, you know, you're distributing it to each term. So that would be negative 3 plus 3 square root of 2. Now that's optional, because I will accept this answer as well. All right, let's try another one. Five over 4 minus the square root of 3. So to rationalize, I'm going to multiply by 4 plus the square root of 3. All right, so distribute in the numerator and get 20 plus 5 square root of 3. And then FOIL in the denominator, that'll be 16 plus 4 square root of 3 minus 4 square root of 3 minus the square root of 9. Middle terms cancel out. So 20 plus 5 square root of 3 over 16 minus 3. So that'll be 20 plus 5 square root of 3 over 13. Now, if you look at these two terms, I can factor out something. It's not going to help me in any way or help me to reduce, but sometimes it will. So it's best to always write it in factored form. So I can pull out a 5, and that will leave 4 plus the square root of 3 over 13, and that's your final answer. All right, this time we have a binomial in the numerator and the denominator, but we're going to do it the same way. So we're trying to rationalize that denominator. So I'm going to multiply by the square root of 5 minus the square root of 3. And I'll do that in both the denominator and the numerator. And then I'll just FOIL in both the numerator and the denominator. So in the numerator, I'll get the square root of 10 minus the square root of 6 minus the square root of 15 plus the square root of 9. In the denominator, I'll get the square root of 25 minus the square root of 15 plus the square root of 15 minus the square root of 9. All right, let's see if we can combine anything in the numerator. And it doesn't look like we can do anything other than take that square root of 9, which is 3. So in the numerator, it'll be the square root of 10 minus the square root of 6 minus the square root of 15 plus 3. In the denominator, these middle terms cancel. The square root of 25 is 5, and the square root of 9 is 3. So I will then put this over 2. And that's the final answer. Let's try another one. All right, again, I want to rationalize. So I will multiply by the square root of 5m plus the square root of p. Okay, so distribute in the numerator and get 3 square root of 5m plus 3 square root of p. In the denominator, FOIL, and it'll be the square root of 25m squared. Outer would be plus the square root of 5mp. Inner would be minus the square root of 5mp. And last would be minus the square root of p squared. Okay, in the numerator, I can go ahead and factor out that 3. So that will be 3 times the square root of 5m plus the square root of p. All right, in the denominator, the square root of 5mp minus the square root of 5mp will cancel. The square root of 25m squared would be 5m. And then the square root of p squared would be p. And that's your final answer.